Okay, so today we have been working on the bishop on our Titan chess set. We just finished the pawn and it went pretty good. So we started in on our second part, and I just wanted to come back since we kind of rushed through some of the stuff at the end. We ran out of time. I wanted to come back and bring a video that kind of helped walk you through the bishop, what I'm now calling the thick bishop. So I'm going to just go through and just kind of walk back through some of the stuff, not only what machining things worked for me and what didn't, but also for just to reiterate the changes that we've made in the profile. So I'm going to go kind of back and forth here. So I'm going to go back to design and go back to my sketch and edit that sketch just a second so you can see what I had. And where we veered from the original bishop is really in this section and this section. So we came in and put a 1/4 inch radius in, or I'm sorry, an 1/8 inch radius in this section, tangent to this section, and then this wall. And then we did a smaller radius down here in this corner. So you have the original Titan that you made, the Titan bishop, and for us it just wasn't going to quite work as well. So this has got 150 thousandths diameter, 75 thousandths radius. Same thing, tangent to the radius, tangent to the angle. I also, just in a way to kind of smooth some things up, I also came in and did a 10 thousandths radius around this, so transition from this edge. So you can see instead of coming up sharp corner, I got a 10 thousandths radius. And then I went ahead and did a 15 thousandths radius on all of these corners, including the bottom of the valley in this groove. Now, where I draw differently, let me back up. I also put radiuses in here, and I think I did probably 10 thousandths up here. You can get in on that. Better grab the right tool. So I got 10 thousandths radius here, and then what do I got down here? $20 thousandths radius here. And honestly, these are just for ease of machining for us. So one of the problems that we had when we come back and forth with changing the original design from Titan versus what we did today is you have two kind of different styles of drawing. So when I draw something, I'm going to draw the half section of it, the entire shape, including all of the radiuses and everything that goes with it. So you can also see we also took the original Titan and we took this shape that has the 4th axis machining on it. We brought in an angle from corner down to about this section and then just filled it in with a radius. So we really modified quite a bit on this part. I'll probably just end up making a new print for it. That way we are able to see all of the changes and designs that we've got. So we've got a 1/4 inch radius on that. That should be all the changes. So I always draw the half section of it and then I revolve it around. Okay, so I'll have my section and I will not finish that sketch. I'll go straight to solid, go straight to revolve, take my axis, which is here, and take my profile, which is here, and then I'll just revolve it around. I'm not going to do it because I've already done it a couple of times. So on this one, I'll finish the sketch back again. And I'm calling it the thick bishop because this section got wider, this section got wider, and then this tapered section here got wider. And on all of our parts, we've added an additional 1/2 inch onto the back side of it just for holding purposes. When Titan originally made these parts, they made it on a live axis lathe. We're making it on a 2-axis lathe and then taking it over to a 4th axis rotary at this point. For these, we'll move into, when we get to the other parts, we'll move into the 5th axis mill. So let me go back. So that gives you just an idea of what that is. And like I said, I'll probably end up making a new print for that in the future. So I go back over here to manufacture where I was, kind of where I started out at. A couple of us had problems with some of our parts not being completely machined. One of my problems that I had in my part is I came back and forth through the part so many times that I had some little fragments of profiles and shapes that that they weren't connected to anything. They were really disjointed. So I had to go back into my drawing, clean all that up, bring it back in here. So if you see, I've got my setup. I'm going to change this one just so, because I don't like the name of it. I'm going to call it Program 1. So I've got a complete working part right now. I'll run it through simulation just so you can see it. So I'm turning the profile here with a profiling tool, and then I come in, I've got a 62 thousandths wide grooving tool. I'm going to grab this groove with it, and then I've got my 125 wide part off tool, which is what you see here for that. So I'm using tools 2, 3, and 4 for that. You wouldn't have to do it like that. You can do it 1, 2, and 3. Typically for us, our part off tool is 4. I already had this tool set up as tool 2, so I just left it alone. But I'm going to go back, and what I'll do is I'm just going to delete all of the machining moves from it. So we'll just delete everything out of here, and hopefully I can recreate it without causing myself too much pain and sorrow. Alright, so that takes care of all of those things. I'll try to remember the things that I added into it as I go. So what I want to do is I want to come in, I've got a couple different options. I can do turning roughing, turning finishing, turning profile, adaptive roughing. I can do a couple different things. So maybe I grab something like profile. My tool that I'm going to select is going to be tool 2 for me. It's my VBMT. I'm going to show it to you. It's a pretty simple, straightforward tool. It's my profile turning tool. This is my insert information. My shank width is really 3/4 of an inch. That's probably the only thing that I would change on that. So let's go 7.5 by 7.5. Insignificant for what we're doing, but it doesn't hurt to know those things. Right-handed. Everything else stays the same there. I did set my surface footage earlier to 600. I'm going to bring it back up to 1,000 for surface footage and leave my feed rate at 12. My post processor. Now you got to have the tool number and the compensation offset be the same for this. So for me it's 2. If you want it to be 1, we can go ahead and change it to 1, and then that way both of those change to 1. So I can accept that and select it. It's now my profile tool. It's got a little bit of a radius on the front. I'm going to walk down through some of the steps here. So turning mode is going to be turning profile. My direction is going to be front to back. I'm going to allow radial grooving, and what that's going to do is it's going to allow this tool to do a little digging out in some of these undercut sections. Well, it'll cut all of these sections, but it'll cut a little bit into this groove as well. Everything else pretty well stays the same. My surface footage is at 1,000. I do not want my spindle to go so fast. So 1,200 is as fast as I want to max my spindle. I can also change that when I post the program out. I'll go ahead and change it here, and I'll probably double check it over there, make sure it's right. I'm going to work from the stock front. I've got my modeled back. I can move it out if I wanted to. Let's just say I wanted to go back 125 with that. So negative 125. Here's one of the things that I really like to change. I'm going to go to stock OD on this, on all of them. And I just really want to be just barely over this thing. So maybe like 50 thousandths. And everything else I think should be okay. Inner radius distance below, I'll go maybe a negative 15. Then I can move on to my next zone. Tolerance on the parts that we're working on, if we're within a thou, that's more than enough. Our compensation is going to be in the computer. Make sharp corners, no. Finishing passes. If I want to have finishing passes, I'm going to leave this alone so that I'm going to let it do a finished pass, but I'm going to actually have it oversized on it. So my step over 40 thousandths, we'll see what that looks like. My feed rate's 12. I'm I'm going to do my roughing passes, my roughing step over, do my stock to leave. I will leave. Oh, let's leave 10 radial. And I'm not really super concerned about axial just because of the way that the whole part flows, but I can put 5 on there just to be on. Actually, there probably will not. So 10 thousandths on radial, nothing on axial. Everything else here, I think I probably can leave alone. Let's see what that looks like. See how messed up it is from before. Okay, so the only thing that I don't like about allowing radial grooving is this chunk back here. It knows that it's going to go back beyond this, and what I want it to do is I actually want it to turn beyond that. If I want to change that, I can do this. So it doesn't hurt anything. It's going to do a nice roughing profile over everything. This one I'm okay with. The rest of these I need. This groove here I need. This I do not need. If I want to get rid of it, I need to come back into here. Whoop. And I need to change this from model back -125 to 0. And then that will probably get rid of that chunk out of there. Now, when I do my finished pass, I need to be maybe moving this back a little bit. Now, the only reason I'm going to do that is because I like to go back the width of my parting tool back. Just give me a visual sight line when I part this thing off. I can leave this alone for now. That groove would not hurt anything. It just looks ugly as I go. So that's my tool 1. I want to come in and then do a finish cut for it. Surface speed should be fine. I'm going to max out here again at 1200. I'm going to finish at let's say 8 for that for feed rate, and we'll just change all 3 of those just because. Now I'll go. Let's see if we can go back the -125 and if it takes care of that section. Let's see, stock. At this point, I really don't need to leave any clearance areas. I can come right up to that part. Tolerance wise, no big deal. No stock to leave. Everything else looks pretty decent. See what that looks like. It does again make that groove. I can trap that in just a little bit, but I either have to make the decision I'm either okay with it or I'm not. And my part off tool is going to go in there next. I'll just be okay with it, I think, today. It does have, we have this gouge into some remaining stock. If I want to get that out of there, go back and just go back to here, change this back to 0, go back, takes care of my gouge, so I have no warning there anymore. This warning is just because I have been taking out moves. I had moves in there and I took them back out. So tool 1, that gives me my roughing on the outside, take about 40-50 thousandths depth of cut. On some of these parts, it's going to be getting pretty small in depth of cut. They get pretty intricate. So here we go. We've got this. It's our finished pass. Next thing I want to do is do the groove. So I'm going to do a new operation, and it's going to be a turning grooving, or turning groove. I already created a tool. I'll show it to you here in just a second. I've got a 62 thousandths wide grooving tool. It's just called 62 thousandths wide grooving. Here's the insert info for it. It's a 16-inch wide, corner radius of 5. Probably need to change the holder size again to match up with that other one, 7.5 and 0.75. It's neutral in its design. Well, it's really right-handed, but it can cut either way. So let's see. We'll leave this tool at 3. So 3 and 3. That way, when I do my tool changes, I end up with T303 rather than something that doesn't match upright or that doesn't tool change. So if it just said T300, we'll know that that's not right. We got to change both these compensation rate and the tool number, or compensation offset and the tool number. Okay, so select that. Now we've got our grooving tool here. Surface footage is 800. We'll try it. Feed rate is at 2000s. That was already set up in the tool. We're going to trap this thing in just a little bit. And so why I want to do this, I only want it to do this groove operation. So what I'm going to do is I'm going to go to front and I'm going to hit selection. And I'm going to hit right on this line. I wonder if I can, gosh, I wonder if I should maybe try to go out just a little bit further from that. I could probably go as far as this line and then this area. My problem with that is I could get potential undercut in that area. Let's try it. Otherwise, I have the potential to get a little scallop right here. So we'll go here, and then for the back side of it, I'm gonna hit selection again. I'm gonna go back here. Now, this is just as before. I don't really care about any of those things. This groove is 100 thousandths wide, or this section is going to be 100 thousandths wide. My maximum grooving step over is going to be 40. I'm going to probably do something like 20. Use some pecking. 50 thousandths, retract 10. Let's take a look and we'll see what that looks like. I'm not going to leave stock. I'm going to go ahead and groove it all the way down to size. That's probably good enough. Let's see what that looks like. May have to come back and do a little bit of tweaking on it. Alright, so I got a problem with it. Axial retract distance. Okay. Let's do this. Let's turn pecking off. See if that helps us out any. You still have a problem there. Let's go back. So now we're going to come in, we're going to hit this, we're going to groove, we go over, step over, and get our other side of our groove. I'm going to go back in here. See if I can turn pecking back on. I don't know if that's enough to let me do that. Yeah, looks like it. Okay, so there's my groove. We can simulate it. So my dilemma in it is that it's recutting diameter as well as the entire groove. So what I might do on a tool like this is I might offset it by about 1/10, just to so it doesn't start to run into my part. Okay, so at that point I've got rough turning, I've got finish turning, I've got my groove right here. I'm going to go into fourth tool and it'll be my parting. Change tools, grab my grooving parting tool. It is this 125 wide. It's got a little bit of corner radius, not too big. All of them seem to be 800, and I'm going to go make all those 750. Go over to the post processor, 4 and 4 for that. So tool 4, offset 4. And then that should accept that. Now, parting should run pretty smooth. If I want to offset a couple thou, I can. If I'm running long or short on my part off tool. Let's see. So I'm gonna go stock plus 1 just because give myself just a little bit to start out from. So tolerance, whoops, back in there. .001. I do not want to transfer stock, so I don't have a second sub spindle. Pecking, I'm going to start my peck depth. Oh, let's see. 50, retract 10, reduce speeds and feeds. This is, I think this is radial on this. I'm going to go at 100. I'm going to reduce it down to 1,000 for feed rate. So that means at 200 thousandths diameter, it's going to slow everything down. So the feed rate and the RPM down, and it's going to come. That way that thing's going to drop rather than spin off like a madman. You do not need to leave any kind of stock on it. And I think I can probably go from there. Okay, so I'm going to go back, run a simulation from the beginning. Yeah. That looks right. So the only thing I'm not super happy about, there's one thing I need to change. So like I said, I don't love the fact that groove tool is going to run on top of that. I will put a chamfer on the back side of this part with that grooving tool though. Need to change spindle speed. I can leave surface footage alone, but I'm going to change spindle speed to like 300. I just don't want that thing to just take off on me. And let's see, it must be here. Edge break, second tab over. I want to do a small chamfer, and let's make it 30 thousandths on the back side, and it'll be a 45 degree. And that should be enough for that whole part. All right, so I'm going to do a save. Now, I already have this NC set up. Let's go back though, and I'm just going to delete it out. And so let's start a new one. So we are using Haas turning. One of the problems that we've had is that we end up doing this a lot, machine simulation, and then it doesn't post out the program. So we need to make sure that we're on something that says Haas turning. There are a couple of options that we have on there. You can go to like an ST10, something 2-axis is what I'm looking for. So an ST10 would work. I'm on just kind of the generic Haas turning option there. So select, and my program, we've already determined it was going to be program 200. So that's our program number. I was playing a little bit earlier with this, and I always toggle back and forth between using a G53 or a G28. So we'll go ahead and use G53. I had it set to G28, but that's because I was just playing with it. We'll leave both axes to doing retract X then Z. That way it can get out if it needs to. Normal information here for sequencing and home positions. I've maxed my spindle out at 1200. Everything else is pretty standard. I need to turn everything on for my setup, and I need to do my post. All right, so when I do my post process, I've got now a G53, so I'm going to go home in X and then in Z. Then I'm going to wrap it or just change tools and then turn my spindle onto 1200, G54 for my work offset, turn my coolant on, go to M6, 10,000ths. I did not do a face off because there's really no face on the part. There's no flat face on the part. Some things I'm looking for is I'm looking for no high RPMs, and I'm looking to make sure that my tool numbers are right as I go. If you're having a hard time searching through this, you can do find and replace. So if I want to find T202, or I don't think there's a 202, so we'll go 303, and it finds the next tool 3, the 03. If I want to, I can go to 404, and it's going to find 404. So that's my parting tool. So that'll help you search through. If you'll notice, the part is going back 3 inches, 861 and some change. Then it's going to do that little chamfering move, and then it's going to peck all the way down, and then it changes feed rates until it's at 200 thousandths. Then we're going to start pecking down at a slower feed rate. So slow feed rate, retract, slow feed rate, retract, slow feed rate, retract, slow feed rate, retract. It's going to go all the way down beyond the center line by 64 thousandths. Wrap it back up to 1.7, then feed to Z 10 thousandths, change spindle speeds, then go back in X and then in Z home. On that one, that's probably better. That's probably a safer way to do it. One of the things that I would probably look at here is I'm at 3 inches, 871 thousandths for my interpolation, and so I'd probably double check myself there. I've made my part a ½ inch long, so that's 3 inches 750, and then I've got another like 120, 125 for my grooving tool. That puts me pretty darn close to where I want for my overall length. I can adjust that on my grooving parting tool if I need to. Everything else I think I feel pretty happy with. Anyways, this is just to help make sure that we have a part ready to run tomorrow. If you don't access the video and don't watch the videos, then that's it's gonna help. It's not going to help you to be as far along as you can be. So the goal is tomorrow that we come into class, we're ready to run the thick bishop, and we'll go from there. And so, okay, you guys have a great day.